Okay, so we're going to, basically this is a lesson 3.4 add-on, or you can consider it notes 2, however you want to consider it. Make the note that these problems are found on page 191, so you know where they came from. It's always useful when you're referring back to your notes. And we're going to start with problem number 37. Let's write the problem down in our notes so we know what it is that we were trying to do. It instructs us to do, so just write that problem down right now in your notes. You have your book open, number 37. Okay, so let's just say this one more time. You have to do number 38 in your homework. Any ideas how you would start this one? Find the value of x so that the ordered pair, unknown x, when y is 12, satisfies y equals 4x plus 8. Courtney?
Could you plug 12 into the y?
Yeah, put 12 into the function for the y and solve the equation for x. There are many ordered pairs that would actually satisfy this function. We're just looking for one of them. We're trying to complete one of them. Okay, so go ahead and solve that because this is solving a multi-step equation of which you know how to do. Find the value of x so that x comma 12, ordered pair x comma 12, satisfies y equals 4x plus 8. So we are saying that when x is equal to 1, y would be equal to 12, right? So we did what they asked us to do. How many more times do you suppose we could do that? If I gave you a different y value, would we be able to find an x? So chances are the domain might be all real numbers. Chances are, possibly, the range might be all real numbers. We don't really know because we're not making the graph for it, but we do know that we have ordered pair 1, 12 that goes with this function. Okay? Any questions? Okay, then let's do, moving on to, I want you to now look at number 41. And again, why don't you write down what it is we're supposed to do. We're supposed to go to the directions. It says determine whether the given points in other words, the ordered pairs are on the graph. That's our instructions. Determine whether the given points are on the graph. Well, we have to have a function that we're talking about first of all. So y equals the absolute value of x plus 2. There's our function. And then we're supposed to decide if 3, 5, ordered pair 3, 5, and ordered pair negative 1, 3 would be on our graph. In other words, do they satisfy this function? So what do you think we're going to do? what in? Yeah, so one at a time we will check to see. So let's do 3, 5 first. We will substitute it into our function, and it has to make it true. The x and the y working together have to make it true. So we're going to put 5 in for y, 3 in for x. What is the absolute value of 3? 3. So all we're doing is just kind of, we're like working down, we're simplifying. We're not solving, we're just checking to see if this ordered pair satisfies this function. 3 plus 2 is 5. So since this is true, right, 5 does equal 5, we could say, what about that point? Let's write it out in a sentence. Yes. Ordered pair, what was it? 3, 5 would be on the graph of y equals absolute value x plus 2, punctuation. So, finishing up answering, because we ended up, when we substituted in, we ended up with a true statement. It checked out, satisfied it. So yes, ordered pair 3, 5 would be on the graph of y equals absolute value x, and then plus 2. Okay, go check out the other one. See if the other one works. So now we have to check out negative 1, 3. Determine if that one would also be on the graph or if it's not. And being on the graph does not mean it can be put on the coordinate plane. It means from that function, would it actually lie on the curve, line, whatever of the graph? Would it be in the table of the graph? Your true statement? Okay, so we can say this one is also. So we're going to say yes, ordered pair negative 1, 3 is, or would be, on the graph of y equals absolute value x, and then add 2, punctuation. Anybody right now just, like, looking at that say, I know a point, an ordered pair, a point that would not be on that graph? Can you come up with one? 1, 5. 1, 5. So x is 1, we put 1 in for x, take its absolute value, add 2, we wouldn't get 5, would we? Do you think when we did use 1, we could get any other? Could we get a y value that would work? What would be the y value if it was 1? What if x was 1? What would the y value be? Wouldn't it be 3? Okay. What do you think about when x is equal to 3? Do you think there are any other y values you could get? Remember, if it's a function, each x has only one y. So if this is a function, then that would mean we'd get no other y values. Do you think there's anything we could put in there for x that would get, when we put, I mean, not anything we put in there for x. When we put 3 in for x, do you think there's any other y value we could possibly ever get? What do you think? Absolute value of 3. Isn't that always going to be 3? And if you add 2 to it, what's going to happen? You're always going to get 5. 3 plus 2 is always going to be 5. There are some things we can say always, right? So it's kind of sounding like, do you think that's going to hold true for all x values? They're only going to have one y value? Maybe you're a little bit concerned about a negative number. So let's look at negative 1. What if when x is equal to negative 1, are there any other y values you could get? the absolute value of negative 1?
1.
Always?
Yes.
Yeah. What's 1 plus 2?
3.
Always?
Yes.
Yeah. Okay. How about 0? The absolute value is 0.
0.
Always?
Yes.
Plus 2?
2.
Always?
Yes.
Huh, sounding to me like this is a function, isn't it? That hx value will only have one y value. Now let's see if we remember what would happen with this being absolute value. You think you know what the graph would look like? Just a rough picture of it, not exactly where it's at on the coordinate plane, just tell me what it would look like. Is it a U? It's really close to a U, but it's not a U. It's a V. Remember, this is the one that does the bounce back. The y values that were on one side, when it makes its turn, the exact same y values start showing up on the other side. And it's a V, but that does happen, I know, in U's also. Okay, let's do one more, and then you can get to work on your homework here. Let's do number 49. So for number 49, the directions say, for each function, find 3 ordered pairs that lie on the graph of the function. So we're going to find 3 ordered pairs. Here are our instructions. Find 3 ordered pairs that lie on the graph of what? What is this one? Oh, no, not an absolute value one. It's y equals 1 1/10 x plus 2. And that's all the information they're going to give us, huh? What are we going to do? Only that much information. Find 3 ordered pairs that lie on the graph of y equals 1 1/10 x plus 2. Yeah, pick some numbers for x. You get to pick them. You get to choose. Okay? So go ahead. You choose. Make a table. You choose. You get to pick your own x values. So you have a column. Remember, just like we did yesterday, we have a column that shows what's the x value you're going to choose. And then in here is our function rule. Y equals 1 1/10 x plus 2. Is that what it is? Okay, and then you have another column that shows the ordered pairs that you're going to have as a result of that. So you need to do that.
How many do you want us to pick?
It says 3.
3?
Yep. Yep, that's all right. So 3. Pick your own, pick x values. You get to pick them. Okay. Anybody do any negative numbers? Yeah, a couple of you did. Okay, see what I said? Remember I said yesterday, if I let you guys pick, you pick numbers you like. Better than whenever you are picking, you should always try to pick some negatives and some positives. Typically Typically, I'm not saying this always happens, but typically it gives you a better graph. Okay, so look at the table up there on my graphing calculator. It says when x is equal to -4, y is equal to -2 4/10. Can you guys see that well enough? Yeah? Okay, and then -3, -2, 1. So I have it all the way through +2 for x. So did you pick any of those values? Check to see if you're right. Do you have the correct y value to go with it? And then after you're done, I will scroll it down a little bit more. Did anybody go above 2 for x? Yeah? Okay. So let's go. See if, there's some more. That goes up through 7 now. You can't read it if the numbers are too small for you. Maybe your table partner can, or you can ask. What does it say for y when x is equal to? Okay, so it said find 3 ordered pairs. So how should your final answer be given as? X, y in parentheses, right? Oh, the ordered pair name. So did you do that? Did you finish it with that column that we have? Okay, does anybody go higher than 7 for x? Anybody use a bigger number than that? Because we'll check it out. No? Okay, so then let me turn this off and get rid of my graphing calculator here, and we will claim to be done today. Okay, anybody have any questions or concerns?